Welcome back to the Chemistry Corner, Episode 2, Time for Titration. And I just want to wish everybody a good afternoon, and to our Polish friends, Dobranoc, and our German friends, Guten Sieben. So we're looking at calculating molarity of your unknown acid from a titration, both a strong acid and a weak acid. So let's do the strong acid first, shall we? See how our class is doing after our last lesson. Now they're a little bit listless. Let's make sure they're paying attention. All right, so in the lab, you titrated your acid, in this case, the strong acid, hydrochloric acid, with sodium hydroxide. Now, we knew the molarity of the sodium hydroxide was 0.10 molar. You had 25 milliliters of hydrochloric acid. Now, I told you the molarity of the hydrochloric acid was 0.100 molar, but I'm looking to see if you can figure out the molarity experimentally. So for many of you, you got your pH, or your solution to change pink after about approximately, let's just say 22 milliliters. So after 22 milliliters, your solution turned pink due to the phenolphthalein. And so we are going to figure out how many moles of hydrochloric acid there are based on the volume of base that we needed. So 22 milliliters, convert to liters. My molarity is 0.100 moles of base. And then if I look at my reaction, which I haven't balanced yet, I apologize for that, you can see that the relationship between hydrochloric acid and HCl is 1 to 1. Therefore, for every 1 mole of sodium hydroxide, 1 mole of HCl, and we go I come out with this many moles of hydrochloric acid. So if that's the moles of hydrochloric acid, and I began with 25 milliliters, I just divide by my volume, which is 0.025 liters, and then I can figure out my experimental molarity. In this case, 0.022 divided by 0.025 gives me a molarity of 0.088 molar of hydrochloric acid. So that's how you would determine your molarity experimentally, and then you can compare it with the theoretical, which I told you was 0.100 molar, and you could calculate percent error. And what about the weak acid section? Well, you basically do it the same way. So I will symbolize your weak acid as HA, plus your base. Okay. Now, at the equivalence point, the moles of base and the moles of acid are equal. So suppose it took me 17 milliliters of 0.100 molar sodium hydroxide to reach my equivalence point. How do I know I'm at the equivalence point? Because my indicator turns color. So I'm going to calculate, just like in the last problem, how many moles of base I have. So 0.017 liters. I converted the milliliters to liters in my head. And 1 liter is 0.100 moles of base. And then your acid. Notice this is a monoprotic acid. If you have a diprotic acid like sulfuric acid, you have to make sure that your reaction is balanced correctly. So we've got 1 mole of sodium hydroxide gives me 1 mole of my acid. And in this situation, out of 0.01 moles, or 0.017 moles of my acid, and then I would just divide that by my volume. Now, for some of you in the lab, you had 25 milliliters of water and 25 milliliters of alcohol when you dissolved your acid. Some of your acids already came as a liquid. For example, the acetic and the sulfuric already came as a liquid, and you only have to divide by then the volume you had, which was in the lab 0.025 liters. Okay? Now, compare this. I'm going to calculate the molarity. Okay, 0.68 molar. Now, the bottles had the molarity on them, so you can compare it to the molarity that was written on there. If you had a solid, let's say you had 0.2 grams of salicylic, well, then you have to convert to moles using the molar mass, and then divide by your volume. In this case, it was 0.5 liters because you had 25 milliliters of alcohol and 25 milliliters of water. Okay, so that's how you would get your theoretical, and then you would compare it to your experimental that we calculated up there. Now, how about finding your Ka?